Okay, this is a continuation of the notes for 10.1 Matrices and Systems of Equation. So we're reviewing those rules for the Gaussian elimination with matrices. So we can see here that we can interchange any two rows. So like you can move the rows around. You can multiply each entry in a row by the same non-constant zero. So this can be negative numbers, positive numbers, fractions, anything you want to multiply by. And then you can add a non-zero multiple of one row to another row. Okay, so just similar to what we were doing when we were solving systems of equations by elimination. So we can use the operations above on an augmented matrix to solve the system. So here's an example of a system that we're going to solve using matrices. So first we're going to set it up as a matrix. So as we reviewed before, we're going to take each of the numbers, and if it doesn't have a number, you put a 1 in that spot. So here's what the augmented matrix would look like. So we got the 2, the negative 1, the positive 1, and the 8. The 1, the negative 3, the negative 2, and the negative 1. Then the 4, if there's a missing number, we need to include a 0 there. So we put a 0, a 5, and the 23. Okay, our goal when we do this is we're trying to get it into this format. So notice how this diagonal right here are all ones, and then these places here are all zeros. So we're trying to get a diagonal of ones. Okay, so that is how we get, when we simplify, we're trying to get to that. So the first thing you want to try to get is a 1 in the first position. Well, if you look at your matrix, you already have a 1 in this row. So we can just go ahead and switch rows 1 and 2. So if we just switch rows 1 and 2, now our matrix looks like this. And now we have a 1 in that position like we were trying to get. Okay, then in order to get a 0 in this slot, so that's what you want to get next. So you get a 1 here, get a 0 here. So we're going to take our first row and multiply it by -2 and add it to the second row. And if it's helpful for you, sometimes I like to take my numbers, and if I'm going to multiply the first row by -2, I might just write it right above it. So this would give me a -2. -2 times a -3 gives me a +6. -2 times a -2 would give me a +4. -2 times a -1 would give me a +2. Okay, and then we're going to add it to the second row. Okay, so that's, we're going to take this and add it to this one. Okay, so that we end up with a 0. We're going to keep the first row exactly the same. So if it's helpful to you, you can rewrite that row. Let me just come down here and write it. So the 1, the -3, the -2, the -1 stay the same. But then I'm going to add these two and write that as my new second row. Okay, so I'm going to end up with a 0 in this position. 6 and -1 is going to give me 5. 4 and 1 is going to give me 5. And then 2 and 8 is going to give me 10. Okay, then it also says we also multiply the first row by -4 and add it to the third row. So I'm going to change colors here. So now I'm going to do that to this row. So I'm going to take that first row again, because again, anytime you have a 1, this is a good place to start to try to get zeros. So we're going to multiply it by -4. So again, I'm just going to write those above here. So if I multiply this by -4, I get a -4. -3 times -4 gives me +12. -2 times -4 is going to give me a +8. -1 times -4 is going to give me +4. And again, I'm going to add that to the last row here. So these I'm adding again. Draw that so it helps you see which numbers we're adding. Okay, and then I'm going to write my new row down there. So a -4 and a +4 is how we're getting the 0. So again, that's what we're trying to get, is 1, 0, 0. So 12 plus 0 is 12. Then 8 plus 5, 8, 9, 10, 11, 12, 13. And then 4 plus 3, 27. Okay, so this is what we have now in our matrices. Okay, so don't try to get ones on the diagonal first. Try to get this first column to match. The 1, 0, 0 is our goal. Okay, let's see. I think that comes up with that same thing. So that's why I wanted to erase these, because that's what we have there. Okay, so notice how row 1 was unchanged. We did that multiplying and adding the rows to end up with what we were at now. And again, that's what we did. So -2 times row 1 plus the row 2. Sometimes you can write that kind of out to the side to help you know what you did. So I'll give you a minute if you need to write down those steps, what we did. We took -4 times row 1 and we added it to row 3. To get our new row 3. Okay, so we're getting closer. We've got the first column to match the way we want. The next place we want to get a 1 in is right here where this 5 is at. So in order to do that, okay, we're going to take our row 2 and multiply it by 1/5. Right? Because if you multiply by this fraction, that 5 became a 1. Okay, and so then everything else got multiplied by the 1/5 as well. So 1/5 times the 5 gave you the 1. 1/5 times the 5 gave you the 1. 1/5 times the 10 gave you a 2. So now this is our new row 2. Okay, now our next step is to try to get a 0 right here where the 12 is. Well, I can use this row right above it, and that's why we want to get the 1 there. Because if I can multiply this row by a -12 and add it to this row, then I can get my 0 right there. Okay, so that's the next step that they're going to do. So let's actually go through and do that. So if I multiply this row by -12, and again, I'm just going to squeeze it right here. So this will give me a -12 when you multiply it by 1. This one, if you multiply by -12, you also get a -12. If I multiply this one by -12, I get a -24. Now I'm going to add that to my third row, and that's what they're going to show you now. So if I add those, I'm going to get a 0. Add this, I'm going to get a 1. Add this, I'm going to get a 3. Okay, so notice that's exactly what they did. So we multiplied row 2 by the -12, and then we added it to row 3. And now we have our new row 3, which is, like we said, the 0, 0 from right there. Put on there. Those made 0 for right here. And then this made your +1. And then this made your +3. Okay, and notice when we did that, that also ended up giving you the 1 here that we wanted. Okay, if you don't end up with a 1 here, then we would just divide by whatever number was there so we could get a 1. So like if that was a 5, we would divide it by 5 so we could get 1. If it was 2, we'd divide by 2. Okay, so now we have what we want right here. Okay, now is where you can take your letters and plug them back in, and we're going to go through and solve. Okay, so when we plug our letters back in, so notice we had a 1, the -3, the -2, the -1. Okay, in the first column we're plugging in the x where the 1 was. And then where the -3 is, we're putting back in y, and where the -2 is, we're putting back in z, and of course it equals the -1. Okay, this one had 0, and then 1, and 1. So we just have 1y plus 1z, and then we had our 2. And then here we just had the 1, because these was 0, 0, 1. So then we just put our z back in there, and we have 3. Okay, so we know what z equals. Z is 3. So that's part of my solution. Okay, now I'm going to plug into this equation. We're going to plug in our 3 because we know z is 3. So now I can solve for y by subtracting the 3 from both sides. 2 take away 3 gives me a -1. So my y is -1. And now I can plug y and z into this equation and solve for x. So 3 was -1 and z was 3. Well, that gives me x plus 3 minus 6 equals a -1. Well, 3 minus 6 gives you a -3. And then if I take that over to the other side, I'd be adding 3. So then x equals 2. So then I can write it there. Okay, so again, the bottom will tell you what z equals. Then you plug z in for this equation and solve for y. Then plug your z and your y into the top equation. Up here will help you to solve for x. Okay, and then if you want to check, you can go back to your original equations and plug those numbers in to see if that actually does equal. Okay, so we got that one. We solved that y was -1. And then when we went through, they just showing you all the work solved and also got 2 for x. Okay, and so then they get 2, -1, 3, just like we got. Okay, and you could plug those back into the original equations and they would make each equation true. Okay, so that is the basics of solving a matrix, and we call that Gaussian elimination, where you're trying to get that diagonal of 1s and everything below the diagonal equals 0. Okay, let's look at row echelon form. So that's what we call it when you get that diagonal of 1s. So if a row does not consist entirely of zeros, then the first non-zero element in the row is a 1, called the leading 1. Okay, so whatever's in your first row should have a 1. For any two successive non-zero rows, the leading 1 in the lower row is farther to the right than the leading 1 in the higher row. So this is what they're talking about. You know, when we had the, not changing, there we go. We had the 1 here, and then the next one had the 1 here, and then the next one had a 1 here. And again, these others can be any letter or number, or not letter, but any number, okay, for the remaining that are left. We're just trying to get there, okay? So then it says and it says if a fourth property is also satisfied, a matrix is said to be in reduced row echelon form. Okay, so this is when each column that contains a leading 1 has zeros everywhere else. So if you continue to do your matrix addition and stuff, you would end up, if you're trying to get it into the reduced row echelon form, it would look like this. And then you'd have numbers here, here, and here. If you continue and get it all the way to just this diagonal as 1s, then your z would equal whatever this number is. Let me put on the highlighter. So if you got it all the way down to what we call reduced row echelon form, then this would be z equals whatever this number is. Your y would equal whatever this number is, and your x would equal whatever this number is. But again, that just takes a few more steps in order to get zeros in each of these places, where once you solve this one, it's pretty easy just to plug them back in. So most of the time, people will just do the row echelon form and not go all the way to the reduced row echelon form. but it's really up to you how you want to solve it. So let's look at this next example. Okay, these are asking us which one of these is in row echelon form. Okay, so what you're looking for again is that diagonal with the ones. So if I look at A has the diagonal of the ones, and then you second thing you look for is everything underneath that diagonal zeros. So yes, A is in row echelon form. If I look at B, I don't have any ones. Okay, so no, that one is not in row echelon form. If I look at C, no, I do not have a diagonal of ones. Okay, I could get it closer to it if I moved this row and this row, if I switched them, but that still wouldn't quite be there. Okay, D is also in row echelon form because I see the diagonal of ones and I see the zeros below that diagonal. But this one is not only in row echelon form, it's also in reduced row echelon form because we see the zeros also above that row of diagonals, that diagonal row of ones. Okay, so both A and D are in row echelon form, but D went a step further and it's in reduced row echelon form. So like they say, matrices A and D satisfy row echelon criteria. And then if you also looked at D, we would call that the reduced row echelon form. Okay, let's do Gauss-Jordan elimination. So this is where we keep doing all of the matrices, adding and subtracting until we get it all the way down into reduced row echelon form. So we're going to get just that main diagonal is ones. All our numbers around it are going to end up to be zeros. Okay, so let's continue the example that we started at the beginning. Okay, so we got this row to be the ones and we got zeros here. So now we're just going to keep going until we get zeros in each of these places. Okay, so remember we started with this column, got the 1, 0, 0, then we got the 1, then the 0, then we got the 1. Okay, for here, in order to work backwards here, I can go and I want to find getting zeros in each of these places. So I'm going to first start with this -3 right there. And I'm going to try to get that to be 0. Well, it'll be easy to make that 0 if I multiply this 1 by 3. So I'm going to multiply this row by 3 and add it to this row. Okay, so notice they're going to take, they started with those zeros. Okay, so they're taking row 3, multiplied it by a 2, and then added it to row 1 in order to get a 0 there. Okay, let me write up what we had before just a second ago. Okay, so we started with this. So 1, -3, 0. No, sorry, that was a -2. This is what we started with, and -1. And then we had the 0, 1, 1, 2. So you have this on your page already. I'll just put it here so it makes more sense. Okay, so that's what we started with. So when they took this row and multiplied it by 2, okay, they're talking about this bottom row. Change colors here, whoops. Okay, so it's like I multiplied this by 2. 2 times 3 is 6. Okay, and then I'm adding it to row 1. So I'm adding these two together. And so when I do that, that's how I'm getting these ones here. Okay, so the 2 and the -2 gave me a 0 right there. 6 and the -1 gave me the 5 right there. And then they took your new row 2. In order to get that one, they took -1 times row 3 and added it to row 2. So if I take my row 3 and instead I multiply it by a -1, this would be -1. 3 times a -1 would give you -3, and I'm adding that to this row, okay, to get that new row 2. Because 1 times -1 your 1 times your negative 1, or sorry, adding, sorry, we already multiplied. Negative 1 plus the 1 gave us the 0 right there. And the negative 3 times the 2, no, adding, sorry, negative 3 plus the 2 gives you the negative 1. Okay, notice I didn't need to worry about the zeros because multiplying anything by 0 is just 0, and if you added it to that row, it would just stay the same. Right, so I'm not worried about the ones where there's zeros. Okay, so that's how I got this new row. Notice row 3 just stayed the same. So now I've got 2 of my zeros that I want. Now I'm going to go to get a 0 in this spot where the negative 3 is. So they're saying we're going to take our row 3 and we're going to multiply it by, take 3 and multiply it by row 2 and then add it to row 1. So let's try that. So if I have my row 2, that's this row here, multiply it by 3. So 3 times 0 obviously is just 0. 3 times 1 is 3. 3 times 0 is just 0. 3 times a negative 1 is negative 3. And then I'm going to add that to my row 1. Okay, and again, I had these numbers on the original row 1. The 1, negative 3, 0, 5 from this row right there. Okay, and that's what we're adding. Okay, so the 0 and the 1 just stays the 1. The 3 and the negative 3 becomes the 0. And then the 0 and 0 stays the 0. And then the negative 3 plus the 5 is how they got the 2. Okay, so now we have it in the row echelon form. And now you can see, and this is the advantage of the reduced row echelon form, is we can see here that these are your solutions right here. Okay, we can see that if we go back and we put in our letters, remember this would be your Z, this would be your Y, and this would be your X. So Z equals 3, Y equals negative 1, X equals 2. That's exactly what we got on that previous problem when we used the other method. Okay, so it's not necessary to get these other zeros. It takes more of this work, and if you don't enjoy this work, you might just want to stop once you get to the diagonal full of 1s. Okay, and so they're just showing you here how you can just take each of those and see exactly what it equals. Okay, we're going to look at some special systems now. So when a row consists entirely of zeros, the equations are dependent. For example, if we have this matrix, okay, and we end up with, we have zeros here. We don't have a 1 in that spot. We end up with a row entirely of zeros. You always want to put that at the very bottom. Okay, so what this tells us is that your Z can equal any number. Okay, where now if I put in for this row, this would be your Y and this would be your Z. So we get Y plus 4Z equals 8. And then for the top row, we have X plus 4Z equals negative 6. Okay, what we need to do here is Z can be any number. So we just leave Z in our solution, and then we're going to solve each of these for X and Y. Okay, so they're going to show you that here, that if we go through and we solve, we would find those solutions. Oh, yes, they don't. Okay, so here it says, when we obtain a row whose only non-zero entry occurs in the last column, we have an inconsistent system of equations. Okay, so like we have here, okay, if you get anything like this where it equals something that's not a 0, okay, that doesn't mean that Z can be any number. This is saying that you have no Z's, but it equals 9. Okay, that's inconsistent. Okay, you can't have no Z's and then it equals 9. 0 can equal 9. So in this case, there is no solution to the problem. Okay, so we'd have no solution. Okay, number 9 on your homework is going to be something like this, and it's going to give you one of those special cases that we just looked at. Okay, so let's go through and actually solve one together. Now this isn't on your notes, so if you want to take out a separate sheet of paper so you can write down how we're solving this one, that might be helpful for you. Okay, we're going to start the same as we've done the other problems. We're going to go through and write it into the matrices. So I'm just taking each of those and writing down the number. So you get a -1, 1, 1, -4. And for our second line, we get a -1, a 5, a -19, a -32. And then for the last row, we get 7, -3, -27, and 0. Okay, so again, I'm going to go through and do my row operations to try to get this diagonal right here to be all ones and see what happens. Okay, so you can decide, and there's lots of different ways that you can approach this. Okay, one thing I might do is I might just take my first row and multiply it through with a -1. And sometimes if it's helpful to you, you can just kind of write out to the side what you're doing. So I'm taking row 1 and I'm multiplying it by -1. Okay, so if I do that, that would give me +1, -1, -1, +4. Okay, so that would be my new row 1. Okay, which is what I want. I want to have a 1 in that first position. So since it's what I want, I'm going to write it down here. Okay, but then I'm going to look at that. I'm going to say, well, if I add this row to my second row, okay, so my new row 1 plus my row 2, so we're going to do row 1 plus row 2, okay, then I can get a 0 in that next spot because I'm going to add these two together. So that's going to give me a 0. And add these two together, that's going to give me a 4. And add these together gives me a -20. Add these together gives me a -28. Okay, then I'm just going to bring my last row down, and then we'll look at what we can do to it. Okay, and so sometimes these take quite a few boxes, right? We're going to have to write our matrices several times. So a lot of times you'll want to get out some scratch paper and write these down. And on your homework, you're required to show your work for problems 6, 7, 8, and 9. Okay, and you'll have to turn those in to get full credit on your homework. Okay, so this one, again, the next place you want to get a 0 is this place right here. So I'm going to take my 1 and I'm going to multiply it by -7 so that when I add those rows, I'm going to end up with a 0. So I'm going to take I'm going to do -7 times row 1. Come on, that better. And then I'm going to add it to row 3. So -7 times row 1. Okay, let's change it colors. So if I multiply this row by -7, and again, I don't have to move that row. This is just so I can do the addition. So this is going to be, and this is where sometimes I just like to write it above. So I get a -7 if I multiply that by -7. And then -7 times -1 gives me a +7. This will be a +7. And then 4 times a -7 is -28. Okay, so then I'm going to add that to this last row in order to get a 0 in that first spot. Okay, so then I'm going to rewrite my matrices. So I'm keeping the first row, keeping the second row, now I'm going to write my new third row. Okay, by adding those together, I get a 0 here. 7 take away 3 gives me +4. 7 minus 27 gives me a -20. -28 plus 0 is a -28. Ah, look at that. I have two rows that match exactly. Okay, remember your next goal is to try to get a 1 in this position right here. Okay, well look, if I go through and I take that row and try to get a 1 in that position, I can just take row 2 and multiply it by 1/4, which we remember is the same thing as dividing by 4. Okay, so row 1 is going to stay the same. The 1, -1, -1, 4. Okay, the row 2, when I multiply that, okay, that's going to give me a 1 in that position. So a 0, a 1. Okay, this one, if I multiply it by a 1/4, is going to give me -5. And the -28 times the 1/4 gives me a -7. Okay, now for the next one, I want to try to get a 0 now in this position. Well, I could use this row that I currently have. In order to get a 0 here, okay, I could just multiply this row by a -1. So row 3 times a -1, and then add it to my row 2. Okay, so let's do that. So if I go through and multiply this by a -1, this is just going to change the signs. So that gives me a negative there, a positive there, and a positive there. And look what happens to each of those. 0, 0, 0. Huh, that's interesting. Oops. Okay, so if we look at this, remember what it said. If you get a row of zeros, okay, that means that z can be any number. Okay, so instead of saying z equals something, we're just going to say this is just z. Okay, so z is just z. Okay, so that is part of our solution. So now to get the next row right here, if I plug in my letters, I have 1y minus 5z's equals 7. Oops, -7. Okay, so now if I want to go through and solve that for y, okay, I don't know what z is. It can be any number. I'm just going to move my 5z to the other side. So I end up with y equals 5z minus 7. So that is what, let's see. Let's move that. Just write it here. Y equals 5z minus 7. Okay, so now we've solved for y. So y is just 5z minus 7. Okay, so I would write just the y part, 5z minus 7. Okay, and then I'm going to solve for x, doing the same thing. Well, I'm going to put back in my letters here. So this would be x minus y minus z equals 4. Well, z is just going to stay. Y we just solved, and it is 5z minus 7, so I'm going to replace that in there. And now I'm going to solve it for x. So I'm going to distribute my negative there and get a negative 5z plus 7 minus z there. We still have our x in the front equals 4. Okay, so combining like terms, I put my z's together. That's going to give you negative 6z. But when I take it to the other side, it's going to become positive. So x is going to equal 6z. And then the 7, when I bring it to the other side, is going to be a negative. Negative 7, positive 4 is going to give me a minus 3. So my x equals 6z minus 3. So I'm going to write that here, 6z minus 3. And so when you type in your solution on these ones, it looks like this. So rather than having a number in each spot, we just have it written with the letter Z. So since Z can be any number, then we got to keep Z in each of the others. So we solved for each variable in terms of Z. Okay, if you want to check your answer, whenever this happens and you want to check your answer, let's just go back to one of our equations up here. Let's pick any number we want for Z. So let's say that Z is 3. Well, if Z is 3, 5 times 3 is 15. Take away 7 would give you 8 for your Y. And then if I wanted to solve for X, I would do 6 times 3 is 18, minus 3 would give you 15. So it means these three numbers should be able to work in any of our equations that we plug them in for. So let's try it in this first one. Negative 15 plus 8 plus 3 should give us the negative 4. Well, negative 15 plus 8 plus 3, well, that gives you a positive, 8, 9, 10, 11. So minus 15 does indeed give you negative 4. So that checks out. Okay, or maybe we try it in the last one there. And we do 7 times 15 minus 3 times the 8 minus 27 times the 3, and we see if it equals 0. Well, if you plug that into the calculator, that does indeed give you 0. So it checks out. But you could pick other numbers. Maybe I want to say that Z is 2. Well, then that would be 10 minus 7 would give you 3 for Y, and that would be 12 minus 3 would give you 9 for X, and you could plug those numbers in. Those would also give you work in any of those. So that's where Z can be any number. Okay, so when you get to number 9 on your homework, it's going to be left in this format where you have Z is some number, and it only happens when you get all zeros. If there happened to be a number in this last place, then there's no solution. So if you end up with something like that, that would be no solution. But all zeros ends up with having a letter Z, meaning Z can be any number we choose. And so we leave all the others in terms of Z. Okay, I hope this helps. I want you to work on the homework as much as you can over the weekend. And then I will give you some time in class on Monday that you can ask questions, or if you need assistance. It might also be helpful for you to go home and just search up other videos on solving matrices, okay, and watch a few more examples, or look at the view and examples on the homeworks. They do take a lot of work, but this is how we solve systems of equations when we have 3 or more variables.